All right, perfect. Well, my name is Joshua Donovan. I am a escalation engineer with the Developer Azure Services org at Microsoft. Right now, I am on the ARM team, so this is a pretty good talk for me because it's close to home in what I do every day. Pretty much today, the goal is going to be to take you from, if you've never heard of ARM before or interacted really with Azure before, it's going to take you from knowing nothing to hopefully knowing more than most. So it can be a quick ramp up of a lot of information. We are going to be having a knowledge goal on this one. So the things I hope you'll understand by the end is what is ARM and how do we interact with it? How do we deploy to ARM? Also, how we troubleshoot there. And then most of the things we're going to keep fairly surface level. So I also wanted to include where to go next if you want to dig deep into things or get really good at, maybe Bicep or Terraform on Azure or something like that. I am providing quite a bit of links and tutorials and things that you can go through on your own time. Of course, I'm also going to have my LinkedIn at the end. So if you want to reach out, if you have any questions, feel free to message me on LinkedIn. But to get started, one of my favorite quotes is "Knowing is half the battle" from G.I. Joe, because I feel like once anybody has at least a little bit of an understanding of how something works and how it's set up, you can move on to dig in and maybe even self-resolve before you have to reach out to someone like me in Microsoft support. So first topic, what is ARM? Azure Resource Manager, or also known as ARM, is the deployment and management layer for Azure. If you've been in Azure for a very long time, you probably remember Azure Classic, or it was just called Azure at the time, where you didn't have any sort of a management layer and you managed each individual resource as its own individual resource. You didn't have any way to really do much in forms of automation or infrastructure as code or anything like that. And that's why Azure Resource Manager was created, is to give you that common layer, that control plane where you can interact with all of your resources using common API techniques and things like Terraform or ARM templates or Bicep or anything else you really want to. Other things that it added were features like granting access control through things like RBAC permissions. So you can say this person can do this and this person can't do this. It also adds things like locks, so you can protect your resources from being deleted, and tags, so you can help with organization if that's within your billing. So you can tag things to know what is, what project's spending all of your money, or tags for organization just for administration purposes. But ARM added a bunch of things to help make the governance and the management of your resources inside of Azure much easier. So ARM is set up in a kind of three-tiered scoping. At the very top level, you have your management groups. So your management groups are a logical organization of subscriptions. In Azure, your subscription is going to be where your billing is tied to. And it's usually what most people think of as your top level organization in Azure. But realistically, you also have these management groups that in a very large environment, you can then split up your subscriptions into different management groups. Like you can have a development management group where all of your development subscriptions are. And then you can apply your certain maybe policies to that management group. And then you can have your production management group, which you may have really locked down through, policies or anything else, or RBAC rules, where you can maybe restrict to only things that go through our deployment pipelines can be deployed to our production subscriptions. But then, developers can have a little bit more of a free reign. So it's a logical organization for management groups of your subscriptions. And then inside your subscriptions, you also have your resource groups. Now, every resource has to be inside of a resource group, but a resource group is an ARM layer logical container, and it's a way to help us organize and identify resources in Azure. So Just to kind of recap, you go from your management groups to your subscriptions, to your resource groups, then to your resources. And the fun parts, when we are interacting with ARM requests, which we will see this in action later, one of the things that I really want to show is how you can debug anything, any request while you're interacting with the Azure Portal or Azure PowerShell, or however you're interacting. We can see here that everything goes through the common layer, like I was talking about, which is Azure Resource Manager. And that common layer is a set of REST APIs for accepting client requests. And with things like the Azure Portal or REST clients or anything like that, you are going to be interacting directly with the REST API. With things like Azure PowerShell or the Azure CLI, you'll actually be going through an SDK, which then will reach out to the REST APIs. So in the end, if you want to get down to the base level of Azure Resource Manager, everything goes through the Azure REST APIs. So there's a concept in Azure Resource Manager of the control plane and the data plane. Like I was saying, when ARM got created, it was created to be the control plane. So ARM is the control plane of Azure, and it's how we interact administratively with our resources and everything inside of Azure. As we interact with the control plane, we can use things like the AZ PowerShell module, CLI, the portal, of course, which is what most people are used to, and SDKs and things. But all of this goes through the control plane, Azure REST APIs, which if you're in public, you're probably going to be familiar with the management.azure.com URL. Of course, if you're in government or a private cloud, those will have their own control plane addresses. But for the most part in public, and this is for global public, it's going to be that management.azure.com. Like we touched on earlier, the control plane added some management features. So we have our RBAC rules, Azure policy, the ability to lock resources from being deleted or updated. And it also provides activity logs. So our activity logs are going to log control plane events. And that is a very helpful way for if something happens to one of your resources, you have access to your activity logs so that you can see what happened. There's a concept in the control plane of greenfield and brownfield. You may hear this thrown around if you're interacting with people that are really familiar with ARM or anything like that, but essentially this becomes really important when it comes to Azure policy, because with a greenfield means it's a brand new deployment. So you're deploying a new resource into Azure through the ARM layer. That would be considered a greenfield resource or greenfield deployment. Then everything else that is already existing or is getting updated, maybe those are going to be considered brownfield. When this becomes important is for things like in Azure policy, you may have access to different information if it's a greenfield deployment, because you would only have access to what is being sent to you through that ARM template. Versus if it's a brownfield deployment, the policy engine might be able to do a GET request against that resource to be able to have more information on it. So greenfield is new, brownfield is existing resources. And then we have the concept of the data plane. So the control plane is ARM, but the data plane is where all of your company's information will be stored, where your applications are running. Basically anything that's inside of a resource provider is going to be on the data plane. An easy way to identify if you're interacting with the control plane or the data plane is if we use the storage account example here, you can see that you are interacting with blob.core.windows.net when you're accessing Azure Blob Storage. And that would be when you're accessing actual blobs. But if you wanted to, you could also interact with the storage account on the control plane layer to do like an administrative action. Maybe you're adding an IP to your access control list or something like that. That would go through management.azure.com. So that would be a control plane action. Whereas if you're downloading a blob, that would be a data plane action. Data plane actions often and mostly require separate credentials. So you're not going to typically use RBAC permissions for securing your data plane operations. If we stick with a storage account, you'll use something like a SAS key or something like that to secure your data plane resources. And then finally, features that enforce management or governance. So again, thinking of like Azure policy or something like that may not work on the data plane. So a popular issue here is with Key Vault or something like that. There is a data plane provider mode. So you can actually do some things through Azure policy inside of the data plane for Key Vault using that Key Vault provider mode. Typically, it has to do with like having certificates expire at a certain time and things like that. Just to finish off that thought, though, if you're going to use a data plane mode inside of Azure policy, I don't think there's any that I know of right now that let you make your own custom policies. Typically, data plane policies, you're going to have to always use the built-ins. Whereas if you're familiar with policy, resource manager modes, you of course can create really whatever you can imagine. But other things like resource locks would prevent your storage account from being deleted, but it would not stop somebody from going into that storage account and deleting all the blob data. So there is that separation between control plane and data plane inside of Azure. Okay, so now I kind of just threw a ton of information out, but we get to have a little bit of fun here. We can start with how we interact with ARM. The first one that we are going to do is the most popular, which is the Azure Portal. So the Azure Portal is interacting with the ARM layer through the APIs, which we're going to show here in just a second. The Azure Portal is, of course, the most common way people typically interact with ARM. In this quick little example, we're just going to show viewing of a resource in Azure, but we're also going to show how you can see those underlying API requests inside your browser, and also how you can collect a little bit of data if you ever need to reach out to someone like me in Microsoft support. So let me get this pulled up. And all right, hopefully everybody can see my portal. So inside of the portal, anything you click on in here is going to be sending a request to that management layer, which is to the ARM layer of Azure. We can see that by opening our browser tools and going to network. And we can see here that I've got it filtered on management. The reason I'm filtering on management is because the URL is management.azure.com that we're going to be typically interacting with. So if I go into this Pittsburgh resource group, we can see I have a storage account here. And we can see these requests starting to come in. So these requests are doing things like doing post request here. And this one is just getting a card information. So you can really dive into how the Azure portal functions just by reading through the APIs that are happening in the backend. One of the things that is unique about the Azure portal and how it functions versus like Azure PowerShell or like an SDK is that everything in the portal is sent through one of these batch requests. So this can get a little confusing for people if they're like if we ask for something like a correlation ID. So correlation IDs are really important for us in support. If any of you have interacted with us before, a correlation ID can help us identify exactly what log we need to go look at so we can see exactly what your request was doing and then hopefully fix whatever issue you were having. If you're looking through the portal for, maybe something's not loading properly, you'll see these batch requests instead of, if you're used to troubleshooting another type of website, instead of the actual API request. So in the batch requests, you can go into payload. And payload will actually show you the underlying requests that are happening. So we can see here that we've got a request to check for advisor warnings. And if I had any, it would pop up. But if I click on the storage account, we can see here that the requests are loaded here. And we can see if I can find the right one for the get storage account. So that's the get SKUs. Okay, so we've got our storage client get account here. We can see the URL here. So this follows the pattern of a resource ID inside of ARM. We can see the subscription that it's in. We can see the resource group that it's in, which is our Pittsburgh resource group. We can then see that it's coming from the provider Microsoft.storage, storage accounts, and then the name of the storage account, which is the example storage account. So this is a way you can see the request. So this is the request payload. So this is essentially the request headers and information and body if it was like a post request or something. And you can also see the response. So the response sent back is going to be the resource object for this resource. If you've done anything with like ARM templates or deployments similar to that, this should look really familiar to you. But this is the resource object for this storage account. And we can also see in here in this response, can I see in responses? So if I go to the preview tab, we can see in responses, we can look at the headers and we can grab that correlation ID. So if you're ever having issues in the portal with maybe like a deployment's not going through properly, or maybe something's not loading like you expect, one thing that you can always do that is helpful is open up your developer tools inside your browser. You can then have your networking tab open, go ahead and do whatever process is causing the error, and then you can export it. So if you click on this button, you'll see export HAR file. So if you export that file, that will then allow you to share that information with whoever's helping you debug, if that's us, or if you're debugging a different website. This is universal, the exporting. It's not really specific to Azure, but it's a good tool to have. We actually have instructions on how to do this in Microsoft Learn and in the resources at the end, where you'll have a long list of links that you can follow. One of those is that document, so that you can go through and maybe do this on your own if you would like at some time. But that is basically how the portal interacts with a resource. You are using the APIs in the background, and it's processing that ARM object and using that information to display it to you inside of the Azure portal. But if we go back to here, and then next thing, so Azure Portal, that one's can be a little boring, I guess, because everybody knows how to use a website. But next we have the Azure PowerShell mode / CLI. So these are two ways that you can interact more programmatically. So like if you want to do some scripting to automate something inside of Azure, that is something you can do. Sean has a question. Is knowing somebody's subscription ID a problem / security risk? It's information, so it wouldn't give anybody access to see anything of yours. Like they would have to have access to your tenant and things like that. If you're concerned with what I'm doing here, this is a demo account, so it doesn't matter that anybody can see my subscription ID. But if you're super concerned about something like that, I can see why, because it is part of every resource ID that you have. But I also, it's not going to grant any sort of access or give any more information other than this is the name of a subscription ID in Azure. But if we look at the PowerShell, I'm going to go ahead and pull up my PowerShell and get that shown. Okay, so I'm going to do PowerShell inside of VS Code. We're going to be kind of hanging out in VS Code quite a bit for the rest of this. But as you can see here, I've got my terminal open and I'm in PowerShell 7. And one thing that we can do here is we can use the AZ PowerShell module to interact with PowerShell, or with Azure, sorry. So the AZ PowerShell module is something you have to install. It does not come with PowerShell. And in that list of links that I was discussing earlier, you will have a link to how to install the AZ module as well. But here, what we're going to do is first we're going to validate. That's really annoying that when I click on my notes, it is hiding my Visual Studio. Sorry about that. So if you want to validate that you have the AZ module installed, you can run just git command AZ. And then I've got a little bit of filtering on there just to make the output a little prettier. But we can see here that the AZ module is installed, and we have a bunch of AZ modules for each resource provider that provides their own portion of the AZ modules. You can read a lot more about how the AZ modules work and stuff inside of course, the AZ documentation. If you want to do a specific action inside of PowerShell, that documentation is going to be a great place to start. But what we want to do, so in the Azure Portal, we viewed a storage account. What we want to do is actually go in and view that storage account in PowerShell. So what I'm going to do is do a get AZ storage account. And you can see I've done this before because it's prompting me. But with this commandlet inside of PowerShell, we're going to specify the resource group name and the name of the storage account. And then that is going to output, if I didn't break anything, there we go. Okay, so this is going to output our storage account information. This is just the basic overview of the storage account in the default way that the AZ module outputs it. You can, of course, output essentially the full resource object like we were viewing in the Azure Portal. But PowerShell does convert it to a PowerShell object and make it a little easier for looking at things if you would like. But one of the main things I really want to show here is with the purpose of interacting with ARM when it comes to PowerShell is what if something goes wrong and how do you figure out what's going wrong? There's a pesky little thing in PowerShell where a lot of the time, if you're interacting with Azure, the error that you actually get presented with may not be at least the most detailed error that was actually returned to the PowerShell client. So one of the ways that you can get around that, and you can use this in any of the AZ modules, is to pass the -debug. It's actually, I've never seen an AZ commandlet that does not accept this. I'm pretty sure it's a requirement for them to be pushed out. But if you pass the -debug, what you're going to get exposed is the actual API calls. So if it'll load. Okay, so we can see here that we've got our actual API calls and we've got our response right here. So if you are interacting with support or anybody else, one of the things that we are, of course, interested in is this header XMS correlation request ID. And this is how you can expose it inside of PowerShell. If you're interacting with the ARM layer and anything goes wrong, of course, you're likely doing something more complicated than just getting a storage account for something to go wrong. But you can, of course, come in here and see the correlation ID. And of course, if there is an error, instead of the body being returned that has your storage account that we're looking at now, it will have the full error that Azure is returning to the client presented here in the debug logs. So that's essentially a very top level how we interact with Azure through PowerShell. Now, if we are a Linux user, let's say we're not using Windows and we're not using PowerShell, well, that's where the AZ CLI comes in. So the AZ CLI, similar to the PowerShell modules, has to be installed. I will also have a link to that in the follow-up links for if you need to install it. But we can check that it's installed in Linux by just doing an AZ version. And we can see here that in my Ubuntu client that I've got the AZ CLI or the Azure CLI installed. So what we can do is we can do a similar command, do the AZ storage account show. And we want to pass our resource group of Pittsburgh and our name of example. SA. 1, 2, 3, 4, 1. Okay. So in the AZ CLI, we again can interact with the ARM layer. We can get our resource. We can see here that the AZ CLI doesn't convert it to any sort of easily readable object like PowerShell does. We get outputted the JSON response for what that storage account is. But similar to PowerShell, if we're having an issue and we want to see what's going on under the hood, we pass a -- debug because it's Linux instead of just a -debug. And then we can see everything that was passed and our output. And we can grab that header for correlation request ID, which is going to be right up here. Now, another thing I did want to point out is you can see here that the AZ CLI, now this is Windows or Linux, is running on top of an SDK. The AZ CLI uses the Python SDK as how it interacts. Whereas if we look at PowerShell, we can see here that it's using .NET. So PowerShell uses .NET on the for its SDK, and then the AZ CLI uses Python as its SDK for how it interacts with Azure. But as we can see here, no matter what SDK you're using the REST APIs for ARM. You can go ahead and hide that for now. And we have the .NET SDK. So if you were wanting to add Azure management into maybe an application you're using or creating or something like that, the .NET SDK is available for you to use. This being a .NET user group, I figured it would be appropriate to do the SDK example in .NET. So I'm going to bring back up Visual Studio Code. We're going to go in here. We're going to go into our C# demo and show our quick little demo here. So for C#, we have several things that we're going to need to be able to interact with the Azure SDKs. In this case, we're doing a just GET request, just like we've been doing through PowerShell and through Linux. So what we're going to need is the Azure.Resource Manager package, but also the Azure.Identity package, because we are not going to be able to have a tool handle that for us. So I'm going to clear the screen there. What I'm using here for credential to make it easy for demo purposes is the default Azure credential. So what this is actually doing on the back end is it is using the login credentials that I've already generated inside of the AZ CLI. It is using those credentials as my default Azure credential. You can, of course, use things like a service principal or anything like that, and I would definitely recommend that if you're outside of a development environment. But this makes it easy to get started with using the SDKs, is you can just pop in the default Azure credential, and as long as you're logged into the AZ CLI, everything works. So what we're doing here is we're going to get our subscription resource, set that. We're going to get our resource group name, and we're going to set that, which we've got defined up here. And then we're going to use the resource group get generic resources. So this is actually going to be a list response, and it'll list out all of the resources that are in that resource group, which right now is just that storage account. So if I go ahead and do a .NET run, I got a CD into it. My bad. Let me go ahead and grab. Copy that. Okay, let's try .NET run again. If it finds everything, we should output our well, it's definitely taking its sweet time. There we go. Okay, so we got our storage account name back. That took way longer than it did when I wasn't sharing, so I'm wondering if something's going on there. Plus solar flares, plus demo kind of teasing. Exactly. But we can see here that I output the resource data and name. So the data returns that full resource object inside of the SDK. And then I just output the name to the console to make it easy. So that's a very brief overview of how you can quickly get started inside of the SDK and how you interact with the with Azure through .NET, through PowerShell, through Linux on the CLI, or however else you really wish. There are many, many options for interacting with ARM. Okay, so finally, kind of a common theme, what I've been trying to hammer home this whole time is however you're interacting with ARM, at its core, you're interacting with the Azure REST APIs. We're going to do a quick little example of interacting directly with the REST APIs. And to do that, we're going to cheat a little bit. I clicked on that, so I went to the next slide. So in Azure, in the portal, I don't know if everybody here is aware of this fun little tool, but we can go to the API playground. So inside of the portal, there's a new preview that is available where you can go to this API playground and you can interact with management or the ARM layer APIs directly without having to worry about pesky things like authentication. It uses the authentication that you already have being logged into the portal. And of course, then just lets you interact with your resources. This is really useful if you're like testing API interactions. Maybe you don't know how to properly pass a body of a put request or something. You can come in here and you can play with it and then take that information that you gather from here and actually add it into your application. So what we're going to do here is we are going to look for our storage account, which I'm sorry, that hit again. And we're going to put our storage accounts resource URI here. The reason is in the API playground, we can see that we've already got the management.azure.com. And then we go ahead and just add in the rest of the URL, which we're looking for this storage account. So if I go ahead and say execute, we can see that it actually failed. So when you're using the Azure REST APIs directly, there's not as much handholding as if you were using something like PowerShell. The good thing is the errors are typically pretty self-explanatory. So we can see here that I'm missing the API version. So whenever you're interacting with the Azure REST APIs, each resource provider actually will have their own API versions. So there's not typically a one API version to rule them all when it comes to the management layers of Azure. So one of the tricks that I like to use if I'm doing this is I will put in API version equals 0. So this way, my error will change from API version, but I don't actually, let's say I don't know the API version for the resource provider and storage accounts for Microsoft Storage. So if I execute this, I will then get back this error code. So no register provider found. So we can see here that there is no provider for the API version 0 for storage accounts. But the beautiful thing of this error code is it goes ahead and gives me all of the valid APIs. So I can go ahead and just copy that and paste it there. And then if I execute, you will see that my response body comes back with my storage account. So if I were needing to add a direct REST API call for getting a storage account into my application, I can now know exactly the format that I need to use and take that off to my application. But that is how you can directly interact with the Azure APIs. Now, if you want to use something like Postman, you'll have to handle that authorization layer and do your request over to logging in, get your bearer token, and then you can do essentially the same thing here. I really like using the API playground because it makes all of that a lot easier. So if we move on to next, we have probably what most people think about, at least this is what I think about when I think about ARM, is deploying. So how do I get my resources into Azure? So how we get our resources into Azure is through several forms. We, of course, have the Azure Portal, where you can go in and use the UI to deploy your resources. But important things for like for running a large organization, we're of course going to be using some form of like a CI/CD, use maybe GitHub Actions, or maybe you're using ADO, some sort of pipelining to make sure that your environment is standardized and that you can make periodic updates to your resources. So one of the things you can think about are ARM templates. ARM templates are kind of the original way you would interact with ARM when it comes to resources. It is the root. It is what, if you look at any of the existing resources in ARM, they're going to show up in a similar format to an ARM template. We, of course, have other support for things like Terraform. So this is, if you're in a multi-cloud organization, Terraform's probably the way you're going, because Terraform supports all the clouds. And of course, Azure, we have a module that we publish to Terraform that we fully support that module. We don't support Terraform, but we support that module. We support and keep that updated so that Terraform always works properly with Azure. We also have kind of the new kid on the block, which is Bicep. Bicep is a simplification or maybe a more developer-focused way to deploy resources inside of Azure. It compiles itself down into an ARM template when it's actually deployed, but it is a way to make developing how your resources are deployed easier. And then later on, we're going to talk about a little bit of a surprise method that I'm really having a lot of fun with. So let's go ahead and jump into it. So starting off with ARM templates, the simplest form of an ARM template is going to deploy nothing, but it is going to have the schema specified. So this is a requirement of ARM templates. It also will have its content version. So if you are basically, you're always going to have it just be content version 1. And then you have your resources. So your resources, as we can see here, it is an array. And this is where you will add in all of your specifications for everything that you're wanting to deploy. What we're going to focus on today is actually, for all of our examples, is we're going to be deploying service bus namespaces. Why are we deploying service bus namespaces? Because they are some of the simplest things to deploy, and hopefully that will allow us to focus more on what we're doing and not get tied up in the weeds of how we deploy a specific resource. So this resource definition would go inside of that array from the previous screen. So we would put that resource definition inside of the resources array. And we have 3 items that are always present inside of a resource. These are required for a resource to exist inside of Azure, and that is the type, which in this case is Microsoft.ServiceBus namespaces. It is the API version. So this is going to be that resource provider API version that we were talking about earlier when we were looking at the APIs. And then the name. So every resource in Azure has to have a name. It'll be part of that resource URI that we were looking at. So we saw on the storage account, the very last segment of that URL was the storage account's name. So everything in Azure needs that name, and it needs to be a unique name, at least within that resource group. There are some resources like storage accounts where it has to be a globally unique name. But a lot of the time it only has to be unique within that storage account. Sorry, not storage account, within that resource group. Other popular things that are going to be there are things like location. So if you're not deploying a global resource, you're going to have to specify what region you want it in. This is going to be your Azure region. So for today's examples, we're going to be using South Central US because that's my favorite region to play in because it's the closest one to me. But you can, of course, use whatever resource you want to specify there. As far as service bus namespaces go, the only real other thing we have to specify is the SKU. So that's why it's shown here. And the SKU for service bus namespaces, the name and tiers both match. We're going to be using basic because it's the cheapest one. Finally, there's a section of just about every ARM template, and that is the properties. So in this case, service bus namespaces don't actually require properties, so we're not going to be seeing much of it. But the property section is where the resource provider customizations come in. So if there is something custom to that resource, it's going to be shown in the resource provider customizations. But let us go ahead and have some fun with an ARM template. I'm going to bring up Visual Studio Code. We're going to jump into our deployments, and we're going to look at our ARM templates. So this is the ARM template that we're going to be deploying today. So as we looked at before, we've got our schema, our content version, and our resources. Those are the three things that we talked about before. I've also added in parameters. So with ARM templates, you can parameterize your templates so that you can pass them in as a command line argument, or you can pass them in as a separate parameters file. In this example, we're going to be passing them in as a separate parameters file. You can see it's just a JSON parameter, but it works just like just about any other programming language. You pass in the parameter, and then you can use the parameter later on. But in our resources for this deployment, we're going to be deploying a namespace. We're going to be using this version for the Service Bus resource provider. We're going to be passing in the name, location, and SKU all as parameters. So if we look at our parameters file, there is a difference between template and parameters that I do want to point out. They look very similar in our top headers, but they do have different schemas. So in our deployment template, you can see that we have a deployment template schema. And then in our parameters, you can see that we have deployment parameter schema. That's something I actually messed up a lot when I was first getting started with ARM templates. And then I would wonder why something wasn't deploying. It's because I copy pasted something from a template when I wanted it to be a parameter, and the schema was the wrong type. So there's something to pay attention to. It will cause an error if it's wrong. But here we can see that we simply have our parameters object, and we're passing through our values for each parameter. And then what we're going to do is we're going to use PowerShell to do our deployment. So if you're doing something in, let's say, ADO or anything like that, a lot of the time you'll actually use an underlying client to make the deployment of your templates. So one popular thing I see is if you have a Windows build agent, you'll just use PowerShell. And you can use a similar command or this command to do your deployment. So what we're using here is new AZ resource group deployment. We're going to specify what resource group we're deploying to. And then we're going to specify the path to our template file, which we can see here. And then our path to our parameter file, which we can see there. And then we can go ahead and deploy it. So I just paste it down here and go ahead and, well, first I'm going to show that this doesn't exist, just to show I've got nothing up my sleeves. We've got only our example storage account inside of the Pittsburgh resource group for now. We're going to go ahead and deploy this ARM template. And then it is going to take just a second to return back, and it'll tell us if it succeeded or not. While it's running, though, one thing to specify is this is part of the AZ module. You can see that it's a AZ new-AZ, that's kind of the indicator that it's part of the AZ module. So if you are having issues with a deployment using something like the resource group deployment command, you can also use the debug flag to see what's going on the, what your underlying responses are. That's a popular way to debug as well. Comes with the name. But as we wait, because presenting things always take a lot longer than, okay, well, we can see here. So we can see that the resource did deploy. We have our ARM template deployed service bus. We can see that it deployed to the right. It's still creating. I know, I'm sorry, I can't use it yet. We can see it's not active because it's not finished deploying, but we can see that the resource was created, and we did use our ARM template to do that deployment. And we can see that it deployed. Here in just a second, we will have our output from that, but for the sake of time, I'm going to go ahead and jump onto the next slide, and we can see that output when we return to it. So next, we have the Azure Portal. So the reason I want to show Azure Portal deployments is there is a nice little trick you can do on most resources when we deploy inside of the Azure Portal. So we're going to jump right back into our examples. And hey, look at that, it returned. So we can see here that our deployment returned and our provisioning state succeeded. and we can see what parameters we passed. And this is the basic output that you would get from deploying the ARM template. But if we want to jump into the portal for a deployment, if you're doing a one-off deployment, this is probably how you're going to do it. We just go to create, and we're going to grab service bus. Go ahead and jump into the service bus creation menu. And we can see here that we just need a namespace. So portal deployed service bus. See if that's unique. Okay, cool. And then we're going to pick our basic because it's the cheapest. You can also configure a bunch of other things in here. So one of the things I do want to show in here is that if we were to, let's say, we'll do something simple like add some tags. So let's say we want to customize this in the portal because it's a nice, easy way to do it. We can say test, or let's say environment. That's a common one. We can say environment, development, and then owner is me. So we added some tags, and then we go to review and create. So what we can do on, oh, is that really true? I think I might have picked the one resource that doesn't have this perk. We're gonna go deploy. We're gonna go deploy a storage account. I know that one works. Okay, so what I'm trying to show here, because that was a failure of how did you put it? The demo gods teasing. Is when you go through and you configure a storage account, random numbers or most any other resource, apparently not namespaces though. If you go to the review tab, one of the things that I really like about the portal deployments is you have this nice download a template for automation button. So if you have a resource that you're not fully, like you don't quite understand how you would configure it inside of an ARM template, but you do know how you would set it up through the portal, because it's got the nice menus. You can configure it however you'd like in here. So go through all of the advanced configurations for your storage account, and then you can click the download a template for automation. This is an amazing way to get a really fast head start if you need to build a new template from scratch and you want to then use it in something like an ADO pipeline or something like that. So you can see here that the generated one gives us all of these options that are all parameterized already for us. And then it goes ahead and builds the template in a way that is completely deployable just the way it is. It also separates out into a parameters file for you and gives all of the parameters that you've already filled in. So you can copy both of these out, or you can just click download. So what download will do is it'll download both JSON files inside of a zip file, and then you can use that for deployment. But this is like, to me, this is the secret sauce. I love using this whenever I need to quickly get something deployed, through a pipeline or something like that. But I want to cheat and use the portal instead because it's easier. So that is a great way you can do that through the portal. All right. But that is essentially portal deployments. That's the main thing I wanted to show, is the ability to export. We, of course, didn't submit our service bus deployment because it hurt me deeply not having that button. Okay, so Terraform. I don't know if anybody here's worked with Terraform yet. If anybody has, it can be fun and it can be difficult. So as far as ARM goes, we have the Azure ARM provider, or the Azure RM provider for Terraform. We also have the AZ API provider, and that is actually a way to directly contact the REST API for something that may not have been actually set up in Azure RM yet. So Azure RM may lag behind what a resource provider has published to their APIs because it's got to be specifically curated and tested to work inside of Terraform before we'll publish it out as part of Azure RM. Whereas the AZ API, you can interact directly with the REST APIs, and that's kind of a workaround for if you're trying to use a newer feature, but you want to use Terraform and that feature is not available inside of Azure RM yet. Go ahead and use the AZ API because then you can do it. One thing with Terraform is you must declare the providers that you're using inside of your providers file. We'll take a look at that here in a second. You also have your common commands inside of Terraform. Terraform is an extremely powerful tool. You can also get extremely deep into how it works, but we're going to stay fairly surface level here. So we've got our Terraform init, so that initializes Terraform to be used within the directory that you're in. It'll load in some files and things like that. You then have your Terraform plan. So I really like Terraform plan because what it does is it'll go ahead and create a plan file, but it'll also run validations and let you know what you're going to do before you do it. You can do similar things with ARM templates and things like that, but I really like the way Terraform works on the plan and validations. Because it creates that plan file, then when we do the Terraform apply, it will go ahead and deploy based on that plan file all of your resources to your designated cloud. And in this case, of course, we're playing with Azure. So that's your main commands, but you also have a destroy flag when it comes to plan and apply. So with Terraform, there's an important thing to keep in mind that Terraform likes to keep its own state. So if you're going to start using Terraform, you want to use Terraform for everything. You don't want to deploy a storage account through Terraform and then go make changes to it through the portal, because then Terraform won't have the proper state for that storage account and it can mess with things. So of course, you also have management commands you can do through Terraform. And if you want to delete a resource that or an entire section of resources that you've deployed, you can use the destroy flag. You can use it with plan, where it'll tell you what will be destroyed, or you can use it with apply, and it'll just go out and do all of the destruction. I don't think I have, yeah. So next we go into Bicep. So let's take a look at our Terraform deployment real quick. That switched over to Bicep. Don't do that. Okay, so similar to an ARM template, Terraform is going to be a set of text files. At first, Terraform is going to look a lot more complicated, but Terraform is a really solid way, especially if you're doing multi-cloud, to do your deployments. So what we have here is we have our main Terraform file. This is where I'm going to deploy a service bus. So in Terraform, the format for how you will deploy things is you specify what it is. So in this case, I'm deploying a resource. Then you specify the module reference to it. So that is going to be the Azure RM provider. And then we're going to deploy a service bus namespace. And then I'm just specifying a name for this resource within Terraform, and I'm calling it just SBNS. I then am referencing the provider specifically. So when we look at providers, you'll see that I've named my provider dev. That's just something I like doing. But then we have our required things that we have to pass to the namespace that we're familiar with from our ARM template, which is the name, the location, and the resource group name, and the SKU. So these are the things that we need to pass. We need to tell it where it's going to deploy. We also need to tell it its SKU, location, and name. So similar to ARM templates, you also have variables. So they're not parameters in this one, they're variables, and you reference them with the var starting, and then you can dot source into which variable you're referencing for each item. So in our variables, we can see here that I've got my service bus name. We're going to name it Terraform deployed service bus. We have our location, which is going to stick in South Central US. We have our resource group name, which is going to be Pittsburgh, and then our SKU that's basic. So before we can go ahead and deploy, we of course have to set up our providers. So in this case, I am using the Azure RM. I'm not using the AZ API, so I don't have to specify it here. You can use more than one provider, of course, inside of Terraform. So I could specify both, but for this case, I only really need the Azure RM. So we specify to Terraform what providers we want them to load, and then we actually specify loading in the Azure RM, and then I've added that alias of dev that I was talking about earlier. We then have our outputs file, which I'm not really using, so it's just there for show. But that is essentially the minimum you need. You need a main and you need a providers for Terraform. I, of course, like splitting things out into variables and showing that you can do that to make things a little bit split out. So in Terraform, what we need to do is we first need to make sure we are in the right directory. So I'm going to go ahead and copy path and cd into this directory. And now I can start running my Terraform commands. So Terraform is just referenced with Terraform. When you install Terraform on Windows, you have to add it to your path manually. In the instructions that I will have linked at the end, you can, of course, add, you can follow those instructions and they tell you how to add the path. But otherwise, you can reference the actual exe specifically. But I've got it in my path, so I can reference it as Terraform. And then I can go ahead and do Terraform init. So this is going to load Terraform inside of this directory. I've done this before, so you didn't see anything pop up. But before, or if this were my first time running it, you would see this Terraform directory pop in, and it would create a couple files. Because I've already run init on this directory, it's not there. But now that we've initialized, we can go ahead and plan our deployment. So we're going to do Terraform plan, and then I'm going to tell it to create a main TF plan, which in this case, it's going to update the main TF plan because it already exists. But with what we're telling it is we're telling it to plan. So it's going to do where it tells us what it's going to do without actually taking any action based on our Terraform files that we have here, our main TF and our variables. So once the plan is done running, we'll then be able to apply. And when we apply, we'll actually see it arrive in Azure. Whereas right now, we don't have our Terraform service bus created yet. It's always fun waiting. So I guess I've been kind of blabbing and just machine gunning information. Does anybody have any questions while we wait for this to finish with its plan? All right, you're out of time now. Sorry, I'm not taking questions anymore. Now you can put questions in the chat like Sean's been doing. If you have any questions, I'd be happy to answer them. But as we can see here, we've got our Terraform plan done. So what Terraform will do is it will create this resource. And we can see that it will create the resource in Azure, and we've got plan. It's adding one resource, and we can go ahead and, as it suggests, do our Terraform apply. So we're going to do Terraform apply, and then we're going to specify that we want it to apply this TF plan. So if you had multiple TF plans or plan files, you could actually apply each one individually. That way you can have basically different states for what your resources are going to be, because you do specify which plan you are applying. But we can go ahead and see that it's going to apply/deploy this out into Azure, and we will see it show up here in our resource group shortly. Waiting on it to apply. There we go. Okay, so now you can see that it has confirmed that it's going to go ahead and start creating. It was probably doing some validation steps there. And now, so what it's done is it's created the deployment, and you can see this still creating. So that's doing a GET request against the deployment to see if it's done yet. So you can see that it's still creating, and it'll just let you know as it goes that it's still creating. But at this point, we can likely see it in the portal, which we do. So now you see that we have our Terraform deployed service bus, and it is deployed through Terraform. So that's another way that we can interact with the ARM layer to deploy resources. One thing to specify is I was... Okay, so I guess it's writing to the TF state right now, so I can't open it. But one thing that I wanted to specify is this is the TF state that I was talking about. It keeps its knowledge of your resource states inside of this file. So if I were to go out to the portal and delete that, it would break the current state for Terraform. So like I was saying with Terraform, if you're going to start using it, make sure to do everything through Terraform. But we have our last deployment method, or one of the last deployment methods, I should say, because we have our secret one that I just shared accidentally. But we have Bicep. So Bicep is a domain-specific language. It's a language created for Azure by Azure, and it is here to help make your life easier. ARM templates can be a bit to work with if you're not super familiar with them, and even if you are, there can be slight spelling differences or capitalization differences depending on the resource provider, and it can make it really frustrating to work with. Bicep is here to make all of that easier. So Bicep provides a common syntax that you can use. It also provides immediate support for anything that is deployed as an Azure service. So there's no need for, like in Terraform, I was talking about the AZ API, how maybe something might take a little bit of time to deploy out to Azure RM. With Bicep, because it's integrated into the system so well, it immediately supports anything that has been deployed as preview or a GA version. It also has a simplified syntax for working with it when we compare it to the JSON ARM templates. So let's jump in and take a look at Bicep. So we're going to do the same thing we've done with ARM templates and Terraform so far, and we are going to deploy a service bus because I like service buses. They're simple. So in Bicep, you can split out your parameters into a separate file, but here I decided to keep it all as one so that you can kind of see a start to finish of how simple Bicep really can be to use. So with parameters, you have these things called decorators that you can add to them. And if you are deploying in a way that you may be accepting command line parameters for these, or you have like in your ADO, you have something where somebody's filling in parameters in some sort of a file, you can specify things like what length you want the, in this case, name to be. So if you have a business requirement that your names need to be at least 6 characters long, well, you can specify that here. And then anybody using this file that's deploying can't make their name only 3 characters long because you've said that it has to be at least 6. You can also add descriptions. So this would pop up if somebody is using like the portal to deploy one of your templates. So after this is compiled into an ARM template, you could have it available to be deployed through the portal. It would give a description of what people are supposed to enter. You default parameters just by saying equals. So what I've done here is I've created a new parameter name, and I've defaulted it to Bicep deployed service bus. So if somebody passed in their own parameter, it would actually overwrite this, but this is just the default. We then have really easy to use functions inside of Bicep. So in this case, we have our parameter of location, and I am using a function to grab the location off of the resource group because I don't want to have to specify it myself. I just want the resource. I want the resource to match the resource group for its location. We also have things like parameter validation. So similar to how we can specify max length, we can also specify, I am sharing the code. Oh my gosh, why is it not sharing? Thank you. Now you should be able to see it. My bad. Okay, so in here, we'll quickly jump through that since you've all heard me talk about it already, but we have our parameter and our name, and we can default it to a value just by setting it to equals. We can then add our descriptors for things like validation for length or for description. We can also use functions, so Bicep functions inside of our parameters to default them to, say, match the resource group location. We then can also validate through things like the allowed decorator. So in this case, we know that service bus only has basic, standard, and premium for SKUs allowed. So we can say, hey, you can't specify anything else because it's going to error. Or maybe in your organization, you only want people using premium because it's got an increased security feature that you guys want to use or something like that. And you can say, no, you can't deploy a basic. You can only deploy a premium in our environment. It's a good way for validation. And then here I've just got our capacity showing that not everything has to be a string. You can specify different data types in your parameters. And then Bicep feels quite similar to Terraform in the actual resource definitions. So in Bicep, we specify that we're deploying a resource. We specify what resource. And then this is the specific API version and provider name for a service bus namespace. And you can get that out of the documentation that we are going to look at in just a second. But we can see here that I've parameterized everything. We're just passing our name, location, our SKU, our capacity, and our tier. So this right here, if you're using Visual Studio Code, there's actually some, if you install the Bicep module, there is a lot of tools that you can use. For example, I can do where I compile it into an ARM template. I can just do that from right-clicking. It's really nice. I can deploy it from here. We're going to use the command line because I want to, but you can deploy directly from here. One of the things that I think is super cool about Bicep is the visualizer. So if you're doing a super complicated resource deployment, right now we're only deploying a namespace. See, that's all you see. But let's say I want to also deploy a storage account. I can go in here, and if I start typing storage and I have this module installed, Bicep actually has preset, I forget what they're called in Visual Studio Code, but basically code snippets that we can use, and it will prompt you for those if you have the Bicep module installed. You can see that I started typing storage account, and it went ahead and created an entire storage account resource for me right there just by clicking on it. I think that's super cool. And then you can, of course, come in here and customize it however you want. But if we look at this mapping, we can see that it has then grown to show multiple resources. And then if you were going to do like a resource group, I think it's resource dash group. Is it not going to prompt it? Okay, but it would show tiers of like if you had both of these inside the same resource group and you were also deploying that resource group as part of this deployment, you would see that they were contained in a resource group. So this visualizer, if you start getting really big Bicep files, is a really awesome way that you can visualize or even use it for your documentation and show what this Bicep file is doing. So I'm going to go ahead and get rid of that. And we are only going to deploy our service bus namespace because we're going to stick with that theme. But this visualizer is very cool. That on that. No. Okay. So we've talked about the ability to use functions, showed the visualizer, and now we are going to go ahead and move forward with a deployment. So just like with our ARM template, it's actually the same command. So if you pass to new AZ resource group deployment a Bicep file, it will deploy it just like if you were passing it an ARM template file. This makes, if you already have existing pipelines that you're using with ARM templates and you've got all your commands set up for your build agents, but you want to migrate over to Bicep, you can simply just modify the path of the template file that it's deploying, but you're still using the same technologies. So, you're not changing 100 things at once if you wanted to migrate over to Bicep. But we'll go ahead and deploy that. And we'll see that it is deploying and it will get pushed out to Azure just as if we were deploying in any other method. So that is going to go. And while we do that, I want to bring up the ARM. Let's see, let's go Microsoft.Service Bus ARM template documentation. So this is one thing now that we've looked at the differences between Bicep, ARM, and Terraform. I want you to be aware of this documentation. I'll, of course, have the link available directly to how to get here. But one of the cool things about the documentation that's available is if you're wanting to deploy any resource on Azure that is a GA resource, it will have its documentation in here created, and it will include every little thing that you can specify for the most part. Sometimes you can find an issue, but what's really cool about this is you can come in here and you can say, I want to deploy on Bicep. So you select Bicep, and then it'll show you everything you can set for a namespace on this API version. And it'll even give you the format and everything that you'd need to do. And then you can just fill in these values with it, whatever you want. And then you can see the difference between Bicep and an ARM template. So ARM template is just the straight JSON. It doesn't have much helpers in your development, but this is what your resource object would essentially look like inside of Azure. And then you also have Terraform. Because we are who publishes and maintains the Azure RM Terraform, we also provide updates in here for how the Terraform should look. Now, in this case, I'm not sure why this is, but for the namespace here, it's actually showing the AZ API provider. So this is how you would interact with the AZ API instead of the Azure RM that we looked at earlier. But you can see that it's pretty similar, and you pass through whatever configuration you want your resource to be, and then whatever flavor of deployment that you want to do on Azure, if that's Terraform, if that's ARM templates, if that's Bicep, all the documentation for the resources is in one place, which I think is great. And then it also has a little link to take you to how you can deploy it, and that will show you the PowerShell, the AZ CLI, and a bunch of different ways you can actually execute the deployment commands. If we look back here, we can see that our deployment is done. We can see that the provisioning state is succeeded, and we can see all of the parameters that we passed into Bicep to make this deployment happen. We look into our Azure resource group and we refresh, we should see our Bicep deployed service bus. So that is a very, very top level look into Bicep. Bicep actually gets really cool when you dig into it. So I would really recommend, there are some great tutorials or walkthroughs on Microsoft Learn, where you actually go through it as a module, a learning path. There are several of those for Bicep, and I would definitely recommend going through those because ARM templates are cool, but you have to do a lot of the work manually. Whereas if you get good at Bicep, you can really own your environment really well. I will have some links to some of those learning paths in the set of links that I've been talking about and promising since the beginning. But if we move on, we now have the secret one that I've been talking about. So I don't know if anybody here has heard of the Azure Developer CLI. I know it sounds like the Azure CLI, but it is not. But the Azure Developer CLI, or the AZD, is a new tool for developers to be able to have full environments set up as templates so they can use them for rapid development. One of the things I really like to talk about when I talk about AZD is the benefits for proof of concept. So like if your company does a lot of work using a specific technology stack, let's say you always use React, you always use an SQL database, and you always use the same essential format for whatever web app you are building, but you need to quickly be able to spin up a proof of concept because your manager had an idea and he wants you to get it done. What you can do with the AZD is you can download that template. It will have your base code already there. So if you have anything specific to your business, you can create your own templates. You don't have to use the ones that Microsoft publishes, but you can download that template. It will have the Bicep files already created for deploying the resources, but it will also have a starter template for your actual coding. So if you need to proof of concept a specific workflow or a specific thing you're trying to do inside of your web app, but you don't want to have to deal with, building the same homepage or copying that code over from another app, this is a really cool way to do that. The typical workflow that you will see inside of AZD is you will search and select your template and then download it. And by download it, I mean you will initialize the project by using the command azd init. You will then run the azd up command, which will use those Bicep files and actually deploy your app all at once. So you say azd up and it deploys. And then what you can do is as you're developing, whenever you want to make a change, let's say you make a change in your web app and you want to see what it looks like when it's running up in Azure, you just say azd up again and it will update that code. It won't go through and fully deploy again. It will just update that code to, let's say, a web app, because that's the example we're going to use today. And then when you're done, because this is a proof of concept, you're not wanting it to live out there forever, and you're not wanting to pay for it when you're not working on it. You say azd down, and it'll delete everything out of Azure, but you, of course, still have your project there that you can use for next time. And then next time when you come back, and let's say you're working on that proof of concept again, you can say azd up, and it'll deploy it again. So it's a really cool way, I think, to engage in rapid development. And maybe you don't want your developers knowing or having to know how to deploy things to Azure. You want them working on the web app. So let's jump into the example real quick for our AZD. So for AZD, we're going to start with an empty directory. You can see nothing's here. I'm not going to go through the deployment process in this new one. I've already got one, in the oven, as they say, because the initial deployment, because this project has an SQL database, it can take a bit. So I've got one that's already created, but we're going to show you how easy this really can be. So I'm going to copy path and I'm going to get into that folder. Of course, I put a space in there, so I've got to quote it. How bad of a developer am I? Okay, so we're in here and we're able to run our commands for AZD. So what AZD is it's a command line interface. So we can see here that I typed in AZD, and then we've got our commands available to us. And the first thing we're going to do is we're going to search for, maybe I want to find a new template to play with. I'm going to go AZD template list. And this will show us the templates available. There's also a website in the documentation for this awesome AZD. This is a community-run repo. So if you create a really cool template, you can come in here and you can publish it to the awesome AZD repo, and it can be available for everyone to use, or you can, keep it all to yourself. But for example, we've got things like starters with Bicep, starters with Terraform, microservices, and I know that makes Sean happy to have microservices stuff in here. But we also have things like React apps with Python APIs and things like that. But one of the things you can do is you can, sorry, I'm grabbing my note, you can init a specific one. So for what we're going to be using here today, I'm going to clear this off so it's not covering the entire screen. But what we're going to do today is we're going to init this project because it's my favorite project. It is the to-do app for C#, and it has a SQL database. So it's as easy as saying azd init and then your template, and then you run it, and it'll download the code into your folder that you're in. And then you can enter an environment name. So my awesome proof of concept. It's a long name, but it works. So it will go ahead and generate a development environment for you. And you can see here that we have our assets here. I guess assets aren't that in, but we have our infra. So infra is going to be our Bicep templates. So this is where AZD has all of our Bicep templates for how it's going to deploy our infrastructure. So this is highly customizable, like I was saying before. But we can see that it's going to deploy an APIM with this, which takes a while to deploy. It's going to deploy an SQL database, which takes a while to deploy, a web app, which is pretty quick to deploy. And then we can see that there are also other things like cognitive services that can be deployed and things like that. So the infrastructure is part of the project. That's one of the cool parts of this. But then you also have your source where you can go in and work on your web app. So in this case, it's a React app, I believe. Did I pick the React one? C#, sorry. But anyways, so yeah, you've got your app here that you can go through and you can play with. And this is just the default app. It's a functioning app that you can deploy. And then you can start modifying from there. So like I said, I already have one that's been created under this folder. It's identical folder structure here, but it's already, I've already run the command. So at this point, if I wanted to stay inside of AZD new and deploy this again, all I would run is AZD up, and it would process out of this info file and then deploy all of our source files to the web app or wherever they need to be deployed to. But I've already run AZD up inside of this folder. So I'm going to go ahead and copy its path and get into it. And we'll clear our screen and we can see that this one is here. So if I go out to my Azure environment and I go back to my home, I have this RG demo. So this RG demo is what was deployed when I ran AZD up earlier today. And you can see here that it has deployed an SQL database. It's deployed a web app. It's deployed a key vault so that you can have, security in mind and built in when you get started. It's also set up logging and everything, basically your entire app environment contained in one. And if I go to, let me see, the web one, we can see here, if I go to browse, that it's a fully functioning app. We've got our to-do list app. It does run on smaller hardware, so things do load a little slower, but cost is something you keep in mind. You can, of course, specify larger stuff in the Bicep files if you would like, but initially it's pretty small. But we can see here that the currently deployed has my little customized delete here that says make list go away. So if I wanted to change that, let's say I want to change this delete label to something else because it's something really easy to change. If I come in here, I can go into the source files, I can go into my web and then into my source and then into my pages, and then go to the home page. And I know that I want it to actually say delete list. I guess I've already updated it here. It used to say make this go away, sorry. But I want this to actually say delete list. So I've updated this and I'll change it just to prove that I'm changing it. So delete list perm, so that we know it is being permanently deleted. So I've made a change now. So let's say I save my change. I don't know why Bicep is still open. Don't save. So I saved my change inside the project. So I now can just run AZD up again, and it should go ahead and publish these changes out to where that web app, when this is complete, will have my change so I can see what it looks like in the actual environment that it's running in. As we all know, if you develop web apps, sometimes if you're using an emulator or doing something locally, it can function and or look different than when it's actually running on the hardware that it'll be running when it's out there. So we can see here that AZD up, when you run it, it goes ahead and builds and packages your software, so what you've built, and then it will go ahead and rerun the Bicep, which one of the things with Bicep is it is a declarative syntax, where if something already exists out there, it's not going to change it. It's not going to delete it and redeploy it or anything like that. It basically just makes sure everything is in the state that you want it. And then what AZD does on top of that is also deploys your code, which I think is really cool. So we can see here that now it's provisioning. So it is going ahead and doing the Bicep to make sure everything is up to date. And then now it is going to move through deploying the code. And then once it's done deploying that code, which can take a minute, I should be able to come back over here and do a refresh, and we should see our make list go away be changed to the delete that we changed it to. So But basically, this is something that I wanted to share since we're talking about interacting with ARM, and this is a developer community. This is a really fast way that you can do prototyping, which I think is really cool. It is a new tool, so I've seen that some people haven't heard of it. It's a brand new tool. It came out, I think, earlier this year, maybe late last year, to be GA'd so that it's available for everybody to use. One of the things that's really cool about it, though, is, like I said, it's open source, so you can go in and see how it's working. You can also go in and create your own templates and whatever you want to do, and you can share them with the world through that community repo as well, which I think is really cool. And that community repo is growing pretty quickly. There did not used to be that many of them, of the templates in there. But we can see that it says your application was provisioned and deployed, and it only took 2 minutes because it was a pretty simple one. So we can see that it deployed the API, which we didn't look at that code, but it also says that it deployed the web service, which is here. So if I go back out and I refresh, it should be changed to our new value after it loads. And yep, delete list perm. So we can see that my change was pushed out into Azure and deployed to the web app. And me as the developer, all I needed to know about Azure was how to type AZD up. Now let's say I'm done for the day. I'm no longer developing, so I don't want those resources out there costing money. So I can go ahead and say AZD down, and it will go ahead and destroy all the databases. That entire resource group will be destroyed, but we'll still have our progress for what we've been actually developing for our proof of concept here. So it even specifies here that it deletes all of the deployed code and resources, but the local code is not deleted. So it gives you a little warning, so you can't do this by accident. Total resources to delete 12. Are you sure you want to continue? I'm going to say yes. And then it goes ahead and deletes. So that's one of the reasons why I think this is really cool, because you can spin stuff up really quick, but you can also tear it down really quick without having to really fuss about inside of ARM. But that is really it for AZD. That's just going to go ahead and work through deleting my app so that that will no longer be available. And we should actually see the deletions. Nope, they're not coming through yet. But some of these resources will take a bit to tear down, so we don't have to wait for that. But that is essentially a quick demo of the AZD CLI, and I highly recommend it if you are wanting to, look into having some fun with Bicep and with having pre-built environments for doing development. So that is the AZD CLI. So after a fairly long talk, I'm sorry if it was going through a lot, but where do you go next? In my opinion, documentation when it comes to ARM is your best friend. If you want to know some secret sauce, us in support, we use the public documentation. It's amazing. It's up to date and it's highly accurate when it comes to ARM. So documentation is your best friend because it is my best friend and I use it every day. I also, if you don't have your own playground subscription or anything like that, I would definitely recommend not being afraid to mess around. There's a lot of free services in Azure that you can mess around with deploying and things like that without actually generating any sort of a cost. Actually, Sean had a talk fairly recently, I think it's on YouTube now, about doing Azure on the cheap. So if you are curious with not being afraid to mess around and poke around and figure out what works, what doesn't work, and play with investigating when things go wrong, I highly recommend it. That's the best way I know to learn, which is go in and break stuff and then have to figure out how to fix it. Another thing I can recommend is training. So at least with our Learn documentation and our Learn site from Microsoft, they are doing a great job with training. I highly recommend the Bicep training modules. They're self-paced, but they are very good. And I would recommend going through those Some of them are part of certification paths, and some of them are their own unique learning paths, but I would definitely recommend going through those. And then, of course, if you are at work and you have a support contract with us, if you're having a problem, feel free to reach out. Or if you are using, something like a system integrator, of course, reach out to them. One of the things I never want to discourage is people feeling like they can reach out for help. So I definitely recommend that. And then for this talk, the links and slides are available on my GitHub. I think they're on there now, actually, but if they are not, the slides have not been exported yet, I will admit, but all the links will be available there, where you can go through and link out to all the training that I was talking about, all the documentation that we've been kind of working through today, and really help you, dive deeper if you want to dive deeper into any of the technologies we've talked about. But that is it for me. If anybody has any questions or concerns, feel free to ask them. Also, you can reach me on LinkedIn at Josh-Donovan, and feel free to reach out through, Messenger, or just add me on there. I'd be happy to get to know you.